Welcome back to Built to Ship, the podcast where we go behind the scenes with founders and product leaders shipping real AI products into the world. Today, I'm excited to be joined by Ben, co-founder and CEO of Espresso.ai, a startup that uses Gen AI and advanced optimization techniques to automatically cut cloud and data warehouse costs by up to 70%. Ben, thanks for joining.
Really excited to be here. Thanks for having me.
Of course. Well, I know I gave that brief intro, but you could probably do a better job of explaining what Espresso does. Maybe give us the short description of what you guys do, and then I'm curious about what you were doing before Espresso and how you came up with the idea.
Yeah, the very, very short description of what Espresso does is we plug into your data warehouse. Today we work with Snowflake and Databricks SQL, and then we make everything run cheaper. And that's pretty much it. It's a very short setup, and you just watch your bill go down, and there's not too much else that you need to worry about. Behind the scenes, we have a few different agents running that are optimizing what's running where and when. You can kind of think of it like having a dedicated team, managing everything 24/7 and making second by second tuning decisions to make sure everything is going as efficiently as possible.
Amazing. That sounds very useful. Sounds like it has a super clear ROI. I love the just watch your bill go down. Where'd you come up with the idea? Were you working in the data warehousing space before, and then Gen AI came out and you're like, oh, here's an opportunity, or were you already optimizing costs in this space, and then you realized, oh, we could just add AI on to help? What were you doing before this?
So before this, I was working at Google in Google Cloud infrastructure. And my job for the last few years of COVID, basically right up until ChatGPT came out, was writing high performance C++ to make everything run really fast and really efficiently. The original idea for the company was basically I saw that ChatGPT came out and started kind of thinking, okay, maybe I should go do another startup. I saw you have a YC hat. I was YC back in the day, 10 plus years ago. Nice. At this point.
Awesome.
And ChatGPT, pretty obviously was a big deal as soon as it came out. And what I wanted to do is I wanted to take it and I wanted to build something that could do my job. So I wanted to build something that could take C++ and write faster C++. As they teach us in YC, the first thing I did was go off and talk to users, and it was never super, super clear who to sell that to. But heard a lot about data warehousing and about Snowflake specifically. I think it's something where people were very excited to pay for faster, more efficient code. So pretty quickly after we started the company, we began working on that, started working on SQL optimization using LLMs, got a few customers, and ended up kind of finding a few other places where good modeling can effectively improve efficiency and cut costs.
Amazing. And when you say good modeling, are you talking about how you're structuring your tables, the old school things like adding primary keys and foreign keys and different things like that? Or
sorry. No, by good modeling, I mean specifically like ML. So where can we use LLMs and AI to understand what's going on, kind of a deeper way at a deeper level than you can do with heuristics, and then use that to make decisions. To get a little bit more into the weeds, what we actually ended up building is a kind of like a Kubernetes scheduler. So the sort of agent that runs 24/7 and makes decisions is a bunch of models hooked together that look at the traffic that you have running on your data warehouse. And they also look at the machines that you have up, the hardware that you're already paying for. And they do the kind of, matching algorithm thing of saying, okay, you just kicked off a dashboard, the first half of the dashboard can run on this other cluster that you already have. And so effectively you get that to run for free. And then the second half of the dashboard maybe has to run on a new machine or get split between a couple different machines. But in practice, you can often go from having 10 clusters up to 6 or 7. And so the modeling bit of that is understanding what resources do I have available? Uh, what resources do these workloads coming in need? And how do I match those things as efficiently as possible? Um, Very similar to Kubernetes, or at Google, very similar to what Borg does. The exception being that you kind of need to interpolate all of these things, right? If you're launching something on Kubernetes, you get to write down, I need this much RAM, I need this much CPU. And here we just have some query text. And so we need something that takes that query text and comes out with, this is how long this is going to take to run. This is how much this is benefiting from parallelism. This is how much this is benefiting from more hardware. Or maybe I can run this on less hardware and get the same performance for a lower cost. All of that sort of stuff is being run through models. Interestingly, Snowflake under the hood doesn't, like, their version of indexes is a little bit different. So they are big on each table is sort of sorted in exactly like by one key. And that gets laid out into a bunch of partitions, and it does a lot of stuff under the hood. But that specific, like, classic example of like, what index do I put on these tables? You can't actually do that in a modern data warehouse.
Got it. Super interesting. And, it sounds like there's a lot of like real-time thinking that's needed that maybe the agents are doing, that the models are doing. What would someone have to do before Espresso to like get this kind of benefit or savings? Or was it even possible? Maybe it's possible that it takes someone 24/7 on top of it. Like how would it work before?
Yeah, so there's some stuff that you can do, but it won't work as well. And the analogy that I use here is sort of like air traffic controllers, right? So if you didn't have air traffic controllers, what's the best that you could do in terms of like laying out an airport, and how many lanes do you need for different flights, and all that? The more technical example, or the literal technical example, is when you set up Snowflake or Databricks SQL, you have a static config that tells you, I'm always going to run this warehouse. Always going to run this workload on this warehouse. Warehouse is what a data warehouse calls a cluster, basically. So you have your BI cluster, you have your ETL cluster, maybe you have a cluster for your analysts. We've also seen people organize this in different ways. So you might have a cluster per department or something like that. But fundamentally, you have a static assignment. And that's just never going to be anywhere near as effective as a real-time assignment. But you literally, like, you can't have a human sit there and route things. You're going to introduce a lot of latency. That's not a real job. I don't think anyone would be good at it. There's definitely better and worse static configs. So the other thing that the modeling allows us to do is predict offline, can I actually run this workload here without introducing latency, without introducing queuing? So practically speaking, what you have is people going from some sort of reasonably built default to, if they really want to invest the time and energy, they can run a bunch of experiments and say, okay, we can we can use a smaller cluster here, we can use a larger cluster there. But it's never going to be anywhere near optimal. Again, for people who are familiar with Kubernetes, this is a very, I think most people who are familiar with Kubernetes tend to think of what a Kubernetes migration looks like, which is a different, unrelated thing. But Kubernetes scheduling is really helpful. And if you think about the efficiency numbers, the utilization numbers that you get with a good scheduler, that can trend towards 80, 90%. Statically, we usually see numbers more in the 40, 50, 60% range. So that's kind of where those massive savings come from, right? If you're going from 40% utilization to 80% utilization, your bill is going to go down a lot, and you're still doing all the same work.
Yeah, and what's great about any cost reduction there is it's real cost reduction straight to the bottom line. Very fascinating. I want to get into a bit more of like what are the LLMs actually doing? What are the agents doing? You mentioned writing code before. Is that what they're doing today? Is it that they are writing code, or have you already written certain jobs that say like spin up a cluster, or like move compute over to this other system, and the agents are just doing tool calls. Can you tell us a bit more about, just at that level, what's the architecture look like? How many agents are there? What do they do? Do they leverage tool calls or RAG, etc.?
Yeah. So, like I said, my co-founders and I are out of Google, kind of the land of not invented here syndrome, and we've carried that over to our company. So everything we have is a little bit bespoke and odd. Um, One of the agents that we're working on is a query optimization agent. So that is literally something where when your query comes in over the wire, the agent will look at it, try to write a faster version, a more efficient version of the same query, and then execute that instead. Uh, that's all a lot of custom work that goes in there. Conceptually, you can think of it like calling out to some API and prompting it to say, take this query and give me back a faster version. In practice, we have to make sure that it's correct. We have to make sure that it's actually faster. And we also don't call it out anywhere because the latency would be too high, and our customers don't really want all their queries live sent to OpenAI or something.
So does that mean you're hosting a model yourself?
We are.
Mm-hmm.
Yeah,
And
all of our models are.
Is that like an open source vanilla model? Do you fine tune them?
We fine tune everything. Yeah, so we've kind of take a variety of baseline models and fine tune them to get them to perform the, frankly, kind of off the beaten path tasks that we have. Sorry, go ahead.
No, go for it.
I was going to say, the other couple agents that we have are doing the, we don't have tool calls. We don't have any RAG. We have a very not standard AI agent stack, I would say. But the other couple agents that we have and the sort of reasoning that they lean on ML for is resource requirement understanding that I was talking about earlier. So the specific things that we have models predicting in prod are, if I run this workload here, is it going to queue or is it not? What workload, like we're halfway through a job, what workloads am I expecting to come down the pipe next? If I run this workload on a smaller cluster, is it going to be slower, or can I do that and just save money? And then past that, all the, it's hitting the regular like Snowflake APIs.
Great. No, I think, and I only call out, ask about tool calls and RAG because they are, such popular techniques. But I think a key, any new technology experiences this, but people think that like just because it's something I've heard about, or just because that's what people have talked about, I need to add that, or MCP, right? Like, oh, I have to have MCP in my system. But the best way to build a good product is to actually solve a problem people care about, and whatever's the best way to solve that problem is what matters. So I think it's great to hear examples that don't just follow the common paradigm. I'm curious to know, like, are all of these things, here's another thing that a lot of people assume, like they think AI just means chatbot only, but sometimes you could have AI running in the background and people don't even know that it's happening. You could market it to your team, or to your customers, but like they wouldn't know if you didn't tell them, right? Is that the sort of situation? Are your AI agents and your LLM features running kind of behind the scenes, or are there any features you have where customers directly interacting with an agent to like talk to it and do these things? Or are they just clicking buttons because that's the best UX for that?
They are basically just clicking buttons, and really our ideal customer experience is that you set us up and then you get an email, from us once a month explaining how much money we saved you, and that's kind of pretty much it. And we, like, a common conversation that we have with customers is sort of the like, well, like, where's the AI? Like, I don't understand. Like, your site says AI. I thought we were getting a chatbot. And my I have a more serious explanation of this, but like the less serious explanation is like, I grew up reading a bunch of sci-fi, and like the AI in sci-fi is not a chatbot, right? It's like you tell the thing to go do something and it goes and it does changes the world on your behalf. And that's kind of what we're trying to build, right? I think the more work that we can take off our customers' plate, and the more we can do in the background without people needing to worry about it, the better. Um, there's a couple utilities we want to put together where I think it's very reasonable to have a chatbot that will let you change your Snowflake settings without having to click through
Hmm.
a bunch of UIs. So
Yep.
that's the sort of thing where we want to make that available to our customers. We have something like that internally that we use to spin up new customers and stuff. So all that stuff's really cool. But the core product is really that like understanding what to run and where is really hard. The best heuristics still kind of fall short, and actually using the innate understanding that modern machine learning systems have about code and runtime and what makes code efficient can get you, can really save you hundreds of thousands or millions of dollars at scale. So that's kind of the core thing that our models do, and not so much the not to rag on chatbots, but that's less of what we're building.
Totally. No, I love that. It's always great again to see different ways that you can use AI, not just in, the most common examples. Before we wrap up, my last question is kind of around how do you monitor and evaluate your system? So you mentioned hey, you're writing queries and you assume that they're better. I'm guessing you can't run the two queries and compare them in real time, because that would defeat the purpose of I'm trying to make this work better. Tell us a bit about offline versus online. I'm sure that you do development evaluation when you're making a new model, but then once it's running, do you have a way to track, is this working well? Do you get alerts? Do you have logging or analytics tools? I think a lot of people are getting into production now and they're starting to wonder okay, I did it. I made this AI system, whether it's a chatbot or something else. How do I monitor and evaluate it in production?
Yeah, so eval is just crucial to everything we do, right? We're coming in, we're telling people we're saving money. We want to make sure that that's true. We're billing them for saving money. When we start talking to customers, the first thing we do is run an eval and tell them, here's how much we think we could save you. Before I worked on storage, my co-founders and I all worked together on Google Search, which is incredibly rigorous about evaluating every single change, whether it's ML based or whether you're changing, one line of regular logic somewhere. On our end, we do a couple different things. So on the query optimization side, one in a completely I think different direction from what most people do. We use formal verification to check for correctness. So you can think of what we're doing as building a neural compiler, and the thing that you really want your compiler to do is to not break all your code. And so as much as there's been improvement on hallucination and correctness and all of that, no one kind of is going to wire up their SQL that they're if you're putting together your quarterly earnings report as a public company, you are not going to run those commands through an LLM and just assume everything's fine. First thing we do is check for correctness with math. Is basically the very short TLDR. And those models are also trained with that as feedback. So you can sort of offline at training time, tell them you're wrong. But online we check for it as well. We have LLMs that then check that things are running faster. So those are more statistical, but kind of the first set of things we built were cost models that can actually understand how long is this going to take to run. And in fact, when we built that is when we sort of realized, we actually have all this other stuff we could do aside from just optimizing code that will still be really important for efficiency. But for actual code optimization, the first thing you want to do is that the query you wrote is correct. The second thing you want to do is that statistically you think it's going to be, faster. And sort of the answer there is the big wins are more obvious, right? If if I have some SQL and I dropped a join, maybe it's 80% faster, maybe it's 90% faster. But it's pretty clear that it is going to be faster and substantially faster. That's kind of how eval works there on the specific make this thing run faster. We also
And
kind of
just real
have,
quick on
yeah,
evals, is this something you mentioned you do a lot of stuff in-house? Is this something you've built, or is there a tool or an open source framework that you recommend for evals?
it's all stuff we built in house. Yeah.
Great.
If you talk to other ex Google people building companies, you'll probably get similarly like, no, we just rolled everything ourselves.
Hmm.
So that's unhelpful for other people building stuff, unfortunately. The other set of things that we do is we have these sort of high level air traffic controller algorithms. And again, we have a custom built eval environment where we can actually take your historical Snowflake logs and we can understand if we had taken these actions, what would your bill have been? So this is how we evaluate new strategies and make sure that things are going well. Ultimately, we benchmark all of that against production and make sure that things are running like according to what the eval thinks is going to happen. Um, Last thing I'll mention is we do A/B tests from time to time. So we definitely will not just do the work twice. That is very clean, and we do that like in our own account. But customers, obviously, one is we don't have the ability to issue queries, and two is that would just be bad. Like that's not a very good experience. But we can definitely shut off for a couple days or a week, and then kind of statistically take a look at, well, oftentimes you're running the same workloads over and over. So is the baseline matching up to what we thought based on how the optimized version ran?
Great. Well, it sounds like you have different approach for, different components of the software,
Yeah.
and that makes sense. And again, sometimes building in-house is the best way to do it. So that's still good feedback for folks listening. Well, we're at time. I want to throw up your website on the screen so everyone can check out Espresso.ai. And yeah, maybe just give a brief 30-second description of who is someone who should click this book a call button, and get
Yeah.
in contact.
If you are stressed about your Snowflake bill or you are stressed about your Databricks SQL bill, you should come talk to us. We can probably cut that by 30% or 40% or more, like in literally like a couple hours of setup max. And you can
Amazing.
book a call. You can also email me. I'm Ben@espresso.ai.
Awesome. Great. Well, I hope folks take you up on that offer, and really impressed with what you've built so far, Ben, and looking forward to following along as you continue to build out the product suite and continue to grow Espresso. Thanks again for coming on.
Yeah, thank you so much. This was fun. Thanks for having me.
Awesome. Well, talk later, Ben. Have a good one.
You too.